Okay, for this problem, we're going to take a look at Newton's law of cooling. So it is telling us that dt, that's the rate of change of temperature, big T, with respect to time, little t, is some multiple of the difference between the changing temperature and the external temperature. So that's what TE represents. Now it tells me an item is removed from a 350-degree oven and placed in a 70-degree room. TE, the external temperature, is 70 degrees. Let's go ahead and write that down. That's our first fact. So again, here's our formula. dt is K times T minus T sub E. T sub E, the external temperature, the ambient temperature, 70 degrees. Now, what is the initial temperature at time 0? What is the temperature that we're working with? Well, it comes out of a 350-degree oven. So if that's the case, T of 0 is 350. And then it says after 60 seconds, the item is 250 degrees. That would mean T of 60 is 250. So this is the information that we have. And we need to set up and solve a differential equation. So first up is to recognize that the external temperature is 70 degrees. Let's replace TE with 70. So dt is K times T minus 70. And we hope this is a separable differential equation. Let's try to get all the big T's on one side and all the little t's on the other. And we get here the integral of dt over T minus 70 is the integral of K dt. First integral is relatively easy with the U substitution. U is big T minus 70, du d big T is the derivative of big T, which is 1, so du equals dt. And over on this side, what do we get? D big T is du, T minus 70 is little u, which of course is the integral of 1 over u du, or log absolute u, which would be log T minus 70. What do we have on the other side? The integral of K would be KT, or KT plus C. We need a C somewhere. Now, what does this mean? Let's take a look at this. This is log absolute T minus 70 equals KT plus C. The base of the natural log is E. This is the exponent. So E to the KT plus C will be the argument T minus 70. What are we going to say there? E to the K little t plus C. E to that exponent equals the argument, absolute value of T minus 70. Well, I can use the rule of exponents to recognize this is E to the KT times E to the C is absolute T minus 70. E is a number, about 2.718, to some arbitrary constant, will still just be an arbitrary constant. So in essence, I get C E to the KT. But recognizing if C is truly arbitrary, it could be positive or negative. That requires me to relax the absolute values. So then we'll say T minus 70 is CE to the KT. So adding the 70 to the left side, we get 70 plus CE to the KT equals big T. So we're going to need that bit of information. And we're also going to need our initial information. Recall, we said that T of 0 was 350. T of 60 was 250. And here's my function T as a function of little t. Big T is a function of little t. I need to solve for these constants. I have a K here. And I have a C here. That's what we need to solve for. So let's work on that. Rewriting it on the left, I will say big T of t is 70 plus CE to the KT. T of 0 equals 350. which means when little t is 0, big T is 350. So big T is 350 equals what? Equals 70 plus CE to the K, now T is 0. And we get 350 is 70 plus CE to the K times 0, CE to the 0. Which of course is just C. So subtracting 70 from both sides, what do we get? We get 280 equals CE to the 0, 280 equals C. Okay, well, that's good. So we're a little bit better now. So now we have T of T is 70 plus 280 e to the KT. Then I need my other bit of information. What was happening at 60? T of 60 was 250, and that's going to enable me to solve for K. So big T, when little t is 0, big T is 250. So we have 250 is 70 plus 280 e to the K times what? E to the K times 60. Subtracting 70 from both sides, what do we get? 180 equals 280 e to the 60K. Dividing by 280, that's 18/28 or 9/14. Is e to the 60K. So the next thing I need to do is I need to take the natural log of both sides. Natural log of 9/14 is the natural log of e to the 60K. What does that give me? Well, the natural log of 9/14, grabbing my calculator, natural log of 9/14 gives me negative 0.4418. And I'm going to actually store all of those decimal places in my calculator as K, equals the natural log of e to the 60K, which is just 60K. So if I divide by 60, take that negative 0.4418, divide 60, that's what K is really going to be. Okay. Negative 0.4418 divided by 60. That is now negative 0.00736. Make sure you keep enough significant digits. 007 is not going to be good enough. That is my actual K value. That's what I'm going to store into K. And once I have that, now I have my entire function. Remember, this is where we were before. So my final function, T of T, equals 70 plus 280 e to the negative 0.00736t. And then what do we want to find? What was the question asking us to do? How much time must pass before the item is 100 degrees? Maybe 100 degrees is when we expect to be able to consume said item. So when do we have 100 degrees? We're looking for, again, our function T of T is 70 plus 280 e to the negative 0.00736t. Our temperature is 100 degrees. We want to find the time. So we certainly can do that. 100 equals 70 plus 280 e to the negative 0.00736t. Subtract 70 from both sides. 30 equals 280 e to the negative 0.00. Whoops. Back here. Again, T of t is 70 plus 280 e to the negative 0.00736 t. Our big T is 100. We want to solve for little t. So replacing big T with 100, 100 is 70 plus 280 e to the negative 0.00736 t. Subtract 70 from both sides. We have 30 equals 280 e to the negative 0.00736 t. Divide by 280. And I have 3/28 equals e to the negative 0.00736 t. What is my next move? Hit both sides with a natural log. Natural log 3/28 equals natural log e to the negative 0.00736 t. Natural log of 3/28 is about negative 2.23359. Natural log of e to the negative 0.00736 t is, of course, negative 0.00736 t. Remember, our question is how much time must pass before we're at 100 degrees? Dividing both sides by negative 0.00736 gives me an answer of about 303 seconds. So it takes a little bit more than 5 minutes, according to this model, for that item that came out of a 350-degree oven to cool down to about 100 degrees.